I usually make videos to be understood at the high school level, but this one is going to be more technical and intended for programmers. Object-oriented programming is seen by many as the default way to write computer code. Try to say something like, object-oriented programming is bad, and you will surely be downvoted online. In this video, I'll look at examples in C++ as an object-oriented programming language, and its predecessor C as a procedural programming language, but the points I raise apply more generally. If we were to write a program where an integer x and a character y, strictly speaking an 8-bit signed integer, were required for some particular purpose, conventional wisdom would be to encapsulate them together in a single class. Suppose we call the class Alice and instantiate it in an object called Bob. Perfectly reasonable C++ code. The compiler will put the int next to the char together in memory. The int takes 4 bytes and the char takes another 1, so in total 5 bytes. There is a problem with having a data structure that's an awkward number of bytes in size when it comes to caching and getting split across cache lines. I won't go into too much detail, but in simple terms, it would lead to bad performance to have such an awkwardly sized chunk of data in memory. The compiler will add 3 random, unused bytes onto the end of the object. Apparently these are called slop, to pad it out to 8 bytes. You can check the size of a class like this by yourself if you wish. This is called packing, and there's a great article about it linked on screen and in the description. This means that using a class takes up more memory than if you were to declare the variables on their own. A single instance is not a problem, only 3 bytes. But if we were to have millions or billions of instances, the difference could be important. Here I am comparing allocating 100 million bobs versus 100 million individual chars and ints. The difference is indeed 300 million bytes. I am then also running a simple loop to change all the 100 million values of x and y, first when they are encapsulated in an array of objects, and secondly when they are 2 separate, unrelated arrays. It turns out there is a slight speed penalty in the case of the classes, mostly because of the fact they are larger. To sum up, the code which uses classes requires more memory and takes longer to run. Another example of this is the use of a getter function. We would normally hide away variables as private and only allow them to be read by a specially designed function. Here I have a trivial example, but one you'll find in every textbook, of how to do this. A function called get_x. Let us run the same timing test to see how long it takes to read the value of x directly into a new array versus using the getter function. It turns out to be nearly 50% longer in the latter case due to the overhead of calling a function. We are therefore paying a performance premium for encapsulation. So OOP is almost always strictly slower than procedural programming. But we knew that already. C++ was first known as C with classes, implying that the C language is of course mostly procedural. If OOP were strictly better, nobody would use C. And yet for high-performance applications like the Linux operating system and Facebook's Z-standard library for zipping, people have deliberately done just that and chosen not to go the object-oriented route. The increased difficulty in programming is worth it because it gets the best results. On the flip side, legions of software engineers are knowingly hobbling the performance of their code by using OOP. How much of the memory on whichever device you're using to watch this video is wasted because of classes, for example? This is worth it to them, because otherwise the human task of coordinating teams of coders will be extremely difficult. In defense of OOP, there are genuine reasons to have a getter function which we saw was slower. Suppose that we had a private variable called window_width. It's obvious what a programmer would expect this to mean, but maybe the variable is stored internally as actually 6 fewer pixels than the actual width of a given window for reasons of efficiency or to prevent some sort of bug. The getter function get_window_width would obviously add the constant 6 before returning the variable, perfectly fine. The private access specifier would prevent a programmer reading the variable directly and forcing the use of the getter. This is good. It stops the programmer misusing the variable. With procedural code, however, there is no concept of a private variable. The question becomes, how could we get the best of both worlds? We could of course write OOP code and then turn it into procedural. There are plenty of C++ to C converters. But the problem here is that they will just convert a class to a struct, and this will still be packed, leading to the same drop in performance we had in the original example. A direct conversion will also keep the getters as functions even when they're not necessary, and so have that performance hit still. How about this? We adopt the convention that we replace an instance of the Alice class, previously called Bob, with individual variables starting with Bob underscore. What was previously bob.x now becomes bob_x. Not much different at all. For arrays, the differences would be somewhat larger, because before we had bob element i.x, whereas now we have bob_x element i. We could write our code entirely in C++ and then convert it to C using this convention. Or better yet, have an automatic post-processor do that for us. Once we have finished and make sure that a given bit of C++ code compiles, the post-processor would go through it and get rid of any non-primitives. No more structs, no more classes, no more getters. It would of course be incredibly complicated, but this could probably be done. Let's assume we managed to do this. We now have our whole team of engineers write OOP code, put it through this converter, compile it, and the result becomes much more performant. Before long, we'll be editing the lower level C code itself and skipping out the converter. And now we'll run into a problem. We might have had another class Charlie with a private integer variable z. It does of course have appropriate setter and getter functions for z. In the OOP version, we instantiated Charlie to an object called Dave. But now, in the faster procedural code, we have Dave_z. Because we no longer have a class, we have no concept of a private variable. A careless programmer is now free to change Dave_z manually, and the compiler will not catch this. This could cause big trouble. As we saw, variables are given private access specifiers because it may be dangerous to change them directly without simultaneously changing other things or notifying other aspects of the program that a change has occurred. To get around this, our team adopts the convention of putting a comment above variables we intend to keep private and name the only functions allowed to interact with them. It is agreed that if one of the programmers sees a comment like that above a variable, they will not change the variable directly, but pick the appropriate function from the comment to change the variable instead. Okay in principle, but this is just a comment. It cannot physically cause the compiler to do anything. If a programmer ignores or fails to notice this comment, it will have no effect. But here is the main point I want to make. Why don't we get our integrated development environment, an AI copilot, or some other tool to handle this all for us? At the touch of a button, your IDE would mark a variable as private, and if someone else using the same IDE on another machine tried to set that variable, it will say, "I'm afraid I can't do that," and slap the programmer's hands away. We will leave it to our development ecosystem to enforce an access specifier for what is otherwise classless code in C. In fact, we would move all aspects of object-oriented programming up to the development ecosystem level. There would be a formal standard for how to officially mark up the code so that a compliant IDE, or indeed a whole family of IDEs, would display what are otherwise disparate variables together as a class. A section of OOP code would be mapped to a more efficient procedural implementation. I'm not aware if such an idea already exists, but if I had to name it, I would call it something like D, Development Ecosystem Encapsulation. There are a few ways this could be done in practice, but it might look something like this. The IDE has two panels split down the middle. In the panel on the left, you type high-level code. And if you type anything that's OOP, it will get highlighted with a little plus sign next to it or something like that. If you click on the sign, it will expand to show what code will actually be sent to the compiler. From the previous example, if you type Alice Bob into the left panel, in the right panel it would declare int bob_x, char bob_y, and have a comment something like instantiate Alice Bob. This tells any IDE following the same standard that this little procedural code block is intended to be the instantiation of the Alice class. What was the constructor previously has also been rolled into this little code block. You could go the other way and type all that into the right panel, and it would create appropriate OOP code on the left. Broadly speaking, there would be pseudo-directives in comments for everything you can do with classes. What is ultimately produced is valid C code, so we could happily use this whole approach for just a subset of a C++ project, and it would slot right in. The IDE would obviously use the Linus Torvalds coding style by default. There are a few optimizations that the IDE itself could do at this point. If you have a getter function, even for a private variable, it could be replaced by accessing the variable directly, which has a higher performance, as we saw before. If there's a genuine operation required to access the variable, the IDE could automatically set the function to be inline, and so on. Another property of object-oriented programming is inheritance. You might have a parent class called vehicle with variables that all vehicles would have, such as top speed. You might then have a child class called car, which inherits the properties of a vehicle but adds variables specific to cars, like num_wheels. Not all vehicles have wheels, but all cars do. This is a concept outside of programming as well. When I was 12, I used an innovative approach called copy-pasting to inherit parts of the parent class called the Wikipedia page on the Amazon rainforest into a child class called My Geography Homework. The downside of simply copy-pasting a parent class, of course, is that any changes like bug fixes to the original would not automatically be propagated to the child after the fact. Also, it would not notify other programmers about the relationship between the two classes, and so would harm reusability. But in the age of Git and all the other modern available tools, this is not an issue. You absolutely do not need a mechanism at the level of the programming language to ensure that code changes propagate forward or to notify programmers. The development ecosystem can easily handle all of that. Again, optimizations could be made, like reusing an inherited method instead of compiling it twice. Templates are also trivial for the ecosystem to handle, so something like a copilot could easily handle them and probably come up with more optimal and creative solutions than a compiler would. The ultimate question you might ask is, why bother? Hopefully, I've motivated the idea that there is a performance gain to be had, but let me expand on the philosophy behind this idea. The point is to draw a line between what is strictly necessary from an algorithm and implementation perspective, and what is important to the broad development and reuse of the code. Let the compiler deal only with making hardware optimizations like loop unrolling and so on. Separately, let the development ecosystem deal with the human-centric or organizational issues like encapsulation. For example, if I tried to set a 32-bit integer to the value of 5 billion, this would be physically impossible, and a good compiler should catch this as a problem. If I tried to set a private integer directly, this is an organizational problem. The hardware will not be able to stop me. A malicious programmer or code injection could always set the value of a private integer directly using a pointer. We can separate these two different concerns. The programming language itself can deal with the hardware requirements, and the development environment can deal with, well, the development. There's a good reason why OOP has evolved the way it has. There's a good reason why there was no line drawn between what the code does and how it's developed. Let's look at the whole concept of comments in programming. In the 1980s and 90s, you would have chunky, often monochrome characters on a CRT screen. If you wanted to annotate a function on line 50, your only option would be to type some characters in a comment on line 49. But now, with at minimum 1080p and often much wider resolutions, multiple monitors and so on, it's plausible to have your code in a panel on the left, and as you scroll past line 50, a whole wiki could appear in a panel on the right with images or even videos to explain the function. For this reason, we no longer have to put the things required to use and understand the code right within the code itself. Another thing which is much more advanced now is automation, of builds, of testing, of version control. As I mentioned, what would be output by my scheme is classless code with a standard imposed only by comments. A compiler would no longer offer any protection. It would be easy, however, to automatically check that any IDE level rules are being followed. So to summarize, object-oriented programming is undeniably just syntactic sugar in some sense. The bare metal on which your code is running cannot handle anything but primitives, signed integers, unsigned integers, and floats of various lengths. The processor knows nothing about classes, private versus public variables, none of that. So in short, my suggestion is just to move that sugar out of the programming language itself and up into the IDE or development ecosystem. As I record these words, I imagine that this video will be controversial. I hope and expect that some viewers will at least have learned something, and ultimately I want to start some sort of discussion. I have no idea if something like this is worth doing, and I don't necessarily have all the solutions. I'm just a lowly physicist. Likewise, if someone has already had an idea like this, understand that I am not knowingly plagiarizing them. This is coming purely from my own ignorance, and I would be happy to delete this video or pin a comment if what I am saying has been invented and implemented before. Thank you for watching, and if you are one of my students, make sure to still use OOP when appropriate.